In this video, we're going to look at something called document type definitions. Remember that document type definitions are a means to define a document type. And by document type, we mean a collection of documents satisfying certain properties. So if you want to define your own XML language, your own set of tags, or your own markup language, if you like, you have to come up with a document type definition. In fact, there are two ways to define an XML language: XML schemas and DTDs. And we will find that XML schemas are more expressive than DTDs. So whether you're using an XML schema or a DTD, the idea is to define the structure of the data to create what is called a data model, a model of the data that you want to represent. For example, what sort of tags you want to use, what sort of elements you want to use, and how they should be nested. Right, the structure of the data, if you like, and the relationships between the data, relationships between the elements, what should be nested within what. And of course, you want XML documents to be readable by people and machines. And that's why the idea of markup, as in providing metadata that is readable by people, and because of the structure, is also in a sense readable by machines, more easily machine processable. So schemas are important because they provide standard structures for data exchange, just like HTML. Right? HTML documents are a standard format for web documents, and instead of just HTML, you can define your own XML language to represent documents which are standard for your business, for instance. And then there are constraints for checking the validity of the format of documents, and that is a means to integrate different types of documents and data, right? Because if you assume that different types of documents and data, they satisfy the same format, then it's easier to integrate them. So let's start by talking about DTDs, and then later on we'll talk about XML schemas. So DTDs are basis for these documents, define the structure of the documents, and you'll find that DTDs do not have a very rich representation of data types, and that's why it's superseded by XML schemas. But we'll start with DTDs because they are simpler. Here's an example of a DTD. You have at the top there a doc type definition for the root element called message, and the message comprises to, from, and subject. And to, from, and subject are hash PC data. When you say hash PC data, it means past character data. In other words, any type of data that can be parsed or can be split up into characters and letters and so on, as opposed to binary data. Right? So PC data stands for parsed, P-A-R-S-E-D, character data, as opposed to binary data. And what you see below the doc type definition is an instance of it, comprising message to ICC students from SingLook subject XML nodes on XML DTD. And below is a graph of the hierarchical structure that you will find in many XML documents. So what you have at the top is the DTD, which comprises a bunch of rules. Each rule is of the form exclamation mark, element in capitals, and then followed by the element and what should be in that element. And below there is an instance of that document type definition with the message as the root element. So you have all kinds of rules. We have already seen examples of element rules. You can define elements with attributes using ATT list rules, and then entity for abbreviations, and notation for linking to external processes. And we'll come to all of that. So DTD elements, that's the main thing you want, and that's the general format. You have the element name and then the content category, which could be in other elements or could be something like PC data. It could even be any or even empty, right? If there's nothing contained within that element. In the element, you can have a sequence of elements. The comma separates sequence, and the sequence is significant, right? So if child element name 1 comes before child element name 2, that means that sequence has to be respected. And then if it's mixed, that means it can be an element or it could be just PC data, it could be a string. So in that example, the message has 3 elements, to, from, and subject, and each of them is a string, right? So what's contained within the 2 elements is a string, what's contained within the from element is a string, what's contained within the subject element is a string. And you can also denote occurrences, 0 or more occurrences of an element and so on. Or you can have the vertical bar, which represents all, right? So this says that the message element is either a string, a hash PC data, or is a 2 element, or it contains a from element, or it contains a subject element. So it's saying that a root element message contains 0 or more occurrences of PC data or to or from or subject. The plus sign here means 1 or more, as opposed to asterisk sign or the star sign, which means 0 or more. So this is the message element containing 1 or more 2 elements. And here the person element has to have exactly 1 name element, followed by 0 or more address elements, followed by 0 or more city elements, followed by 0 or 1 gender elements. And that whole thing can occur 0 or more times. Here's an example of an instance of that rule. And so you see the rule in white below, element person, which comprises name, address, star, city, star, and gender, question mark, and the whole thing can be repeated 0 or more times. And you'll find that that example satisfies that instance, right? Because there's only exactly 1 occurrence of the name element inside the person element, and there's 1 occurrence of address, since you can have star address, which means 0 or more. So if you have 1, that's fine. City is city star, that means 0 or 1 occurrences of the city elements. Here there's 2, that's fine. Gender is 0 or 1 occurrences, and there's 1 occurrence there, so it's fine. Here's another example. You have a name and then Mr., Miss, or Doctor, and then followed by those elements. Some of them are empty, that means there's nothing contained in that element. So here's an example of the element, the dr element. So, and you notice that you have something called dr slash, and that's just an abbreviation for the start tag followed by the end tag with nothing in between. And of course, with DTDs, you notice that there's a tree structure, and certainly you can try and guess what the tree structure look like. Right? So on the left hand side is the DTD, and the right hand side is just one possible graphical depiction of that tree structure. Here's another one, and that is the notation that we will use in this subject. So if you're asked to draw a DTD tree in an exam, you want to draw something like what we have on the right hand side. So you have company followed by the address, followed by CNAME, followed by personnel, and then you have an attribute. Notice that there's something called an ATT list, which says that license is an attribute of type C data. C data is the same type as PC data, is character data, and license is an attribute of the company element. Okay? And we represent an attribute in a tree by using an arrow with a label A, as you see on the right hand side. So license is an attribute of company, personnel is an element that belongs to company, CNAME is an element of company, address is an element of company. So the A on top of the arrow represents attribute. And hash implied means that it's an optional attribute. So you'll find that in HTML, for instance, you have some attributes which are optional, some which are not, and if it's hash implied, it means that that attribute is optional, so you don't have to have it. Instead of hash implied, you might have something called required, which means that you need to have that attribute. And then address itself comprises a street, city, state, and a zip element. And then you have the personnel element, and if you look at the rule for the personnel element, it has person plus. That means the personnel element would have 1 or more person elements, and you can see that on the right hand side on the tree as well. There's a plus on top of person, and then you have the person elements. Person elements comprises the name, optionally an email, optionally a URL, and then one or more uh, fax numbers, and you can see that depicted on the right hand side, the tree structure. And name itself is the family or given or middle, and you can see how that's represented there, and so on. Defines attributes, so it's saying that the attribute name belongs to the element name and then the type, and then you can specify the default value of the attribute as well. And then you can say whether the attribute is optional or required. So remember, you have something called hash PC data. So hash PC data is when the contents of the elements is a string. But if the contents of the value of an attribute is a string, then we say C data. So C data is really the same as PC data. So, but if it's an attribute, we call it C data. If it's an element, we call it PC data. It's just the convention. And you also have entity references, which are special characters like %LT, %GT, right, for less than, greater than, and so on. For special characters, you use %. And what sort of types? You can have an enumerated choice list, so you can say that type is an attribute of the element transaction, and the value of type can be debit or credit or 1, 2, 3 or 4, 5, 6, and is required. So it is, you have to have an attribute to be legal in this document type, if you like. And this is an example there. So you notice that type is the attribute of transaction and having the value of debit in that example. Another type for DTD attributes is also ID, and ID just means that the value of that is unique within the entire page. And you can see that in the HTML examples that we have covered. Right? We use an attribute called ID. ID equals to some value, and the value of the attribute must be unique within the page. So the type of that is ID. So here's an example. You have trans_ID as an attribute of transaction, and the value of that is some identifier, some string, which has the type ID, which means that in this case T1 in the example has to be unique within the page, T2 has to be unique within the page. There cannot be two transaction elements with the same trans_ID value. ID ref is something like a foreign key in relation databases. You have a value that refers to the ID of another element. So for instance, you have an element called transaction, and it has an attribute called trans_ID, and the value of trans_ID is of type ID, right? So it's a unique string such as T1. And then you have another transaction element, and for example, it has an attribute called overrides, and the value of the attribute overrides is of type ID ref. In other words, the value of the attribute overrides should be the value of some existing ID, namely T1 for instance. The first T1 is the declaration of that transaction, so it's a unique value of that ID. And then the second one, which is the value of overrides, is just an ID ref. It's a reference to that other ID. So it's like a foreign key, if you like, in databases. And then, as you've seen, you can declare attributes to be required or optional or implied, if you like. And here's an example to say that books can have one publisher but one or more authors. And here's an example of that. So you have IDs, author IDs, and then you have one or more references, right, called ID ref. So the value of pub ref is ID ref because it's referring to an existing pub ID 011. And the value of AUTH ref or author ref is ID refs. Author ref is actually a sequence of IDs. Okay, so entity is just a short form as you have seen. So instead of .txt, you want to have a short form called intro. Instead of chap1.txt, you have abbreviation called chap1 and so on. So notation is something we don't use very much, but we won't go into this very much. So DTDs can be declared within the same XML document, or it could be located in its own .dtd file and linked to from an XML document, in which case it's called an external DTD. Right? So we'll look at examples of both. So this is an internal DTD because you notice that you have a XML document with the root element message, and inside that XML document is the DTD itself. So it's called an internal DTD because the DTD is in the same document or in the same file as the XML document itself, right? So the DTD and the instance of the DTD are in the same file. In external DTDs, imagine you have the file called message.dtd that contains the doc type definition, right? And you just take the doc type definition and put it in a separate file, call it message.dtd, and you just link to it using that declaration there. Okay, couple of other examples. Here you have an XML document called person.xml with a link to its definition located in a file called person.dtd.dtd. So this is just a way to say that this particular XML document, person.xml, is an instance of the DTD defined in person.dtd.dtd. And then if you look into person.dtd.dtd, you can see all the element rules. Here's a full definition of the customer element, and note that it's a top-down kind of definition from elements to attributes, and then the elements contained within the elements, and so on. Right? So you can take a careful read of that. Okay, so in here is an example of an XML document that conforms to the DTD that you saw on the previous slide. And you can check that it is indeed the case.